Okay, so the question that we want to ask here is which of these can be calculated? So we have sizes for matrices A, B, C, and D, and we want to know, like in number 1, for example, if A times B is defined. So A is what? A is a 2 by 3 matrix, 2 rows and 3 columns. B is a 4 by 2 matrix. So we can see in this case that the number of columns in matrix A is not the same as the number of rows in matrix B, so this operation is not defined. And we'll just abbreviate that with ND, not defined. Okay, well, what about B times A? So we'll play the same game. Matrix B has 4 rows and 2 columns. Matrix A has 2 rows and 3 columns. And so we can see the number of columns of B is the same as the number of rows in A. So in this case, matrix multiplication is defined, and the size of the result would be a 4 by 3 matrix. Okay, so now that BA is defined, we know for number 3, this piece here, B times A, that's a 4 by 3 matrix. And then we want to subtract 3 times D. Now D is a 4 by 3 matrix, and multiplying by this scalar will not change that. So that's another 4 by 3 matrix. So component addition, well in this case subtraction, subtraction is defined, and the result would be a 4 by 3 matrix because the operation is defined component-wise. For number 4, A times C. Now AC, there's parentheses around that, so we would try that first. So AC, let's see. Hold on one second. Let me just fix that up a little bit. Okay, so A is 2 by 3. And C is 3 by 4. So that is defined, that the multiplication is defined, so the result of A times C would be 2 by 4, not 2 times 4, 2 by 4, 2 rows, 4 columns. And so that 2 by 4 would multiply D. D is a 4 by 3. So that operation is also defined because the number of columns of the product AC is equal to the number of rows of D. So the result of that would be 2 by 3. So that's going to be a 2 by 3 result. And we want to add to that A, 2 times A. A is 2 by 3 as well, so the component-wise addition is defined. And so the result there is going to be this size, 2 by 3. I'm sorry if this doesn't look fabulous. I'm actually not using great technology to write on the screen, and so it's not turning out so fabulous, so please forgive that. But you should, all these calculations really should make sense to you. Number 5 here, we can see C multiplies the sum of B and D. But if you look at the size of B and D, this operation of addition is not defined because B is size 4 by 2 and D is size 4 by 3. So the component-wise operation of addition is not defined. So addition, B plus D, not defined. Okay, what about DC times B? Well, DC, let's think about that. D is 4 by 3, and C is 3 by 4. So that component-wise, or excuse me, matrix multiplication there is defined. 3 by 4. So these agree. So that the operation of multiplication is defined, and you get a 4 by 4 result. So it's 4 by 4 is the size of the result of D times C. So now you take that 4 by 4 and then you want to multiply by B. Well, B is 4 by 2. So this is DC. B is 4 by 2. So that operation is also defined because you can see the number of columns and the the left factor is equal to the number of rows in the right factor. So it is defined. So the result of that operation is going to be a matrix of size 4 by 2. And this last case here, well, so really, if you compare 6 and 7, it's really about associativity because the order is the same. From 6 and 7, DCB and DCB. So the order is the same. It's about associativity if we multiply B times C, and then, can we multiply that result by D? So really this, when you compare these two questions, the question's really about, is matrix multiplication associative? So, well, let's just do it, grind through this. D is a 4 by 3 matrix, and that's on the outside, but on the inside, what we're multiplying is C, which is a 3 by 4, and B, which is a 4 by 2. Okay, so these, the number of columns in the left factor is equal to the number of rows in the right factor. So the matrix multiplication is defined. So when you group BC, the result, we still are multiplying by D, which is a 4 by 3. But the result of the product CB, that result is a 3 by 2. And so that, that product is still defined, and the result is 4 by 2. So it is the same size as in the previous case.